Welcome to Module 3, Maintaining and Querying a Database Concepts video. Databases, by virtue of what they do, are not stagnant. They require constant maintenance. What does maintenance mean exactly? Maintenance, by database definition, means the process of adding, modifying, and deleting data in database tables. One thing I can't stress enough, data is a valuable asset. You have to be careful when working with data. After the first two modules, we know how to enter new data into a table. However, there are two actions we can perform on data. We can modify data in a table, that is, change the field values for a record. And then there's the most dangerous action of all, deleting data, removing an entire record from a table. Why is this a dangerous action? Well, everyone knows the indispensable undo action. I know for myself, I use undo all the time when I'm working in certain programs. However, when working with data in a database, any database, there is no undo button. If you change or delete data and those changes have been saved to the table, there's no turning back. Now, this is true of Access or any database system. So, if you work in the field, the rule when modifying or deleting data is to be very careful and always make a backup of the data before going Frankenstein on it. Now, one of the coolest features of Access is the ability to query data from underlying tables. Queries, of course, allow us to ask questions about the data. Questions such as, what customers are from Scottsdale that own a pit bull? Or, what invoices are dated between June 1st and July 31st that are greater than $100? With queries, we can do some pretty amazing things. Access provides some pretty powerful abilities that allow us to, of course, display selected fields and records from a table, allow us to sort data in different ways, perform calculations within queries, generate data within the queries for forms, reports, and other queries. Queries can also be used to update data in the tables the queries are based on. Now, there are some exceptions to this, though. If a query uses more than 4 tables, oftentimes the query data cannot be updated. The same is true if it's a totals query. And we can also find and display data from 2 or more tables. Now, when you include more than one table in a query, the 2 tables used must have a common field, a primary key foreign key relationship. If the tables do not, when you run the query, a Cartesian product will result. A Cartesian product is where every record in one table is matched with every record in the second table. This is also known as a cross join, and it's undesirable. Tables are the foundational objects in a database, but queries are the true muscle of it. Before working with queries, let's talk about query basics. The first question to answer, how do you run a query? In Query Design View, a query is run by clicking either the Run button or the datasheet icon, both of which are found in the upper left corner of the design window. Since queries provide valuable information, it makes sense that we should be able to sort them. Queries can be sorted in a very basic manner, or you can sort them in more elegant ways. There are certain ways that you can sort data in fields. There are 2 types of sorts that you can apply to a field. You can sort it ascending, and this applies an A to Z sort on text fields, a smallest to largest sort on numeric fields, and an oldest to most recent sort on date fields. Or you can sort it descending, which is just the opposite of an ascending sort. In a query, you can sort the results on more than one field. If you sort a query on more than one field, the leftmost sort takes priority and is sorted first. The field to its right is then sorted next, and so on. Notice I did not say leftmost field. This brings us to the next basic rule, the fields you can have in a query. In a query, you can include the same field more than once. Now, this is important for 2 reasons. 1, so advanced sorts can be formed, and 2, to create totals queries. In Design View, we can control a lot of what happens to the records we select in the query design grid. First, we can use 1, 2, or multiple tables within the query itself. Second, we can select specific fields from a table or multiple tables to be displayed in the query results. Once our fields have been selected, we have several options that we can apply to those fields. Using the sort line, we can sort the fields. Using the checkbox on the show line, we can choose whether or not to show the field. Why would we choose not to show a field if we selected it for the query results? Two reasons you might choose not to show it would be, one, if the field is being used with criteria. Say if an animal breed field we used the criteria pit bull, but didn't want the results to display because of the stigma with the breed. The other reason would be to perform an advanced sort. See the first concept video for that example. The most powerful options come in the form of the AND criteria line, which allows us to select certain records to display in the results based on the criteria we specify. So as an example, we use the criteria pit bull for animal breed. This will return records where an owner has a pit bull. If we add criteria on the same line, say for last name, we use the criteria Smith for that field. We've just created an AND query. Our results will display records where the animal breed is a pit bull and the owner's last name is Smith. The query will only show results where both criteria are met, and criteria narrows down the selected record. The other criteria option is the OR criteria line. With OR criteria, we can expand the records that are selected. With an OR criteria, you'll need to have criteria for a field on the AND line for it to work. Using the same example, we use the criteria pit bull for animal breed on the AND criteria line. On the OR line, we add the criteria Smith for last name. Now our query produces results where an owner has a pit bull as well as owners with the last name Smith, regardless if they own a pit bull or not. AND and OR are also known as logical operators. With them, we can narrow query results or expand them. When using criteria for queries, comparison operators are used. These allow us to specify conditions for records to be selected. The most common comparison operator is equals. This specifies an exact match. This is also acts as a default comparison operator, meaning you do not have to place an equal sign before the criteria. Access assumes equals and defaults to this. Using the last name example, typing in Smith in the criteria line, Access automatically sets it to equal Smith. You just don't see the equal sign. The other common comparison operators are not equal to, less than or equal to, greater than, and greater than or equal to. Remember the rule, less than points away from the number and greater than points at the number. When dealing with date criteria, if you want to find dates before a certain date, use less than. Dates after a certain date, use greater than. Four special comparison operators include between and. The between and operator will return values that fall between two values, including the values you specify. So, for example, you specify criteria between 10 and 100. This will return records where the values are 10, 11, 12, up to and including 100. There's also the in operator. With the in operator, you use a values list. It's basically an elegant OR criteria. So instead of using criteria for animal breed that looks like pit bull or Yorkie or poodle, an in value list would set the criteria as in, and then within parentheses, the words pit bull, separated by comma, then Yorkie, separated by comma, and then poodle. Third, there's the like operator. The like operator is a pattern matching comparison operator that uses wildcards, the most common of which is the asterisk, which will return an infinite number of characters. As an example of how it can be used, if you wanted to return all records where the last name of an owner started with S, the criteria would be set as like S asterisk, and S and asterisk would be within double quotation marks. This will return all records where an owner's last name starts with the letter S. Finally, there's a special operator called isNull. Null is a special value. It means absence of a value. If a field doesn't contain a value, that field is said to be null. You can use the isNull criteria to return records where a field does not contain a value. Going back a couple slides, I talked about using and OR criteria. This is what's referred to as using a multiple selection criteria. And OR criteria are logical operators. We use comparison operators for criteria, and we use logical operators for multiple selection criteria. With an AND operator, we will narrow down the selection. For example, if on the same criteria line I want to display records where the owner's last name starts with an S and their animal was born before January 1st, 2015, the query will only display records where both criteria are met. a total of 10 records are returned. However, with an OR, we can expand the selection. Using the same example, if we move the date criteria to the OR line, our query will show owners with a last name that starts with an S, along with animals that were born before January 1st, 2015, regardless of the owner's last name. In this case, a total of 31 records are returned, changing it to an OR selection criteria. Two additional items that queries are excellent for include calculated fields and creating totals queries. Within a query, you can include calculated fields that can be used to perform calculations using existing fields in a table. Calculated fields are created using basic or complex mathematical expressions. Needless to say, if you're going to work with databases, a basic understanding of at least business mathematics is required. In Table Design View, Access does have a field data type called a calculated field. So why not just use this instead? Well, there are two very good reasons to ignore that data type and never use it. First, using a calculated field type uses unnecessary space in tables and thus the hard drive. Calculations can be done in the queries themselves, and the results will be produced when you run the query. Thereby, you don't need to store them. The second reason, if you ever decide to upgrade an Access database to a backend server, such as SQL Server, calculated fields are not supported. A calculated field is not an actual data type. Bottom line, create calculated fields in queries, not tables. An example of a calculated field that produces the tax amount based on a field called invoice amount would look like this. When creating a calculated field, the name of the field is first and the calculation second, separated by a colon. Very important. The name first, colon, and then the calculation. Without the colon, Access will complain and tell you there's a syntax error with your expression. So again, don't forget the colon. Total queries are a special type of query that allow you to view summarized data. When you first create a query, it starts out as a select query by default. You have to change it to a totals query for it to become one. You'll know it's a totals query when you see an additional line in the query design grid named total. With a totals query, you can view data in aggregate form. Aggregate form refers to viewing data as a sum total, average, minimum, maximum, or as a count. With a totals query, you can add the same field more than once. So if you wanted to see the sum, average, minimum, and maximum of the invoice amount field, you'd add 4 invoice amount fields and apply each separate aggregate to the separate fields. To further define totals, you can also incorporate group by fields. And these fields will let you specify aggregates based on the separate values contained in the group by field. For example, the reason field in the sample below contains various values. Using the invoice amount field, I can see what the sum and average is for each of those reasons. Decline. The sum of all invoices for that reason is $745 with an average invoice amount of $106.43. With most queries, you can update the data that appears within them. You cannot update data in a totals query. This is because the query is not displaying individual records, but rather a composite of many records. So let's jump ahead of Module 3 a bit and talk about 2 additional enhancements that can be added to queries. The first of which is a concatenated column. Concatenated columns allow us to combine the contents of 2 or more text fields into one field. To concatenate columns together, we use the ampersand character to combine, or as I like to say, glue the fields together. Concatenated columns are great when you want to combine a person's first and last names together to create a full name field. For example, to do this, like a calculated column, we first give the column a name, full name in this case, and then add a colon after the column name. From there, we add the first name field followed by an ampersand. For readability purposes, a space should be placed between the field names, so we add that space using 2 quotation marks with the space in between. Within those quotations, anything can be placed, by the way. After the quotations, we add another ampersand followed by the last name field. Now we have a field that will display the full name of the person shown within the record. As I mentioned, you can include any text within a concatenated column as long as it's enclosed within quotation marks. Another example, We could create a column that displays the first name and the city associated with the record. In between, we could add, within quotations, is from. So when the query runs, the field would display Mary is from Scottsdale or Joe is from Mesa. Another enhancement we can include in queries are functions. Functions, like their mathematical counterparts, take in a value and return a value. One of the most useful functions in Access is the immediate if function. Using an immediate if function, you can return a specified value based on a test condition. An immediate if function contains three parts, also called arguments, separated by commas. The first part of an if is the test condition itself. The test condition will be based on another field in the query or field in the table or tables used in the query. Test conditions will use comparison operators. The second part is the value that will be displayed in the field if the test condition evaluates to true. And finally, the third part is the value that will be displayed in the field if the test condition evaluates to false. An example of this would be a field named large amount. Using an if function, we test the invoice amount field. If invoice amount is greater than $100, the value in this field will display yes. That's the true part. If the invoice amount is less than $100, the value in the field will display no, which is the false part. Another example of this would be a field named invoice age. Using an if function, we test the invoice date field. If the invoice date is after January 1st, 2016, the value in this field will display new invoice. If the invoice date is before January 1st, 2016, the value in the field will display old invoice. The last function we'll go over is the date part function. The date part function will return the numeric portion of the part of a date that's specified, such as date, month, or year. Date part has two parts, or arguments. The date part in the form of the initial for date, month, or year, and the field used to get that numeric value. An example of this would be a month number field that will return the numeric value of the month from an invoice date column. The exact format would be date part and then in parentheses M in quotations followed by invoice date, separated by a comma. Another example of the same type would be a field that displays the date value using the same invoice date column. The only difference is substituting M for D in the first argument. Now, Access supports literally hundreds of different functions. These are just two of a mere sampling of those, and all functions can be used within queries. That wraps it up for Module 3 concepts. Next up are two videos covering Module 3 skills. The first video will go over query basics, and the second will cover more detailed querying skills. After viewing the videos, I encourage you to take the quiz while the material is still fresh.